So we're into the third installment of our SAT Prep mini-series, and we're going to work with math with calculator this time. Again, we're not following the chronological order of the test, so it doesn't really matter which one I do at this point. I'm just choosing the ones that I happen to choose for this day. Alright, so math with calculator strategies, okay? Since we're doing math with calculator, it's safe to assume that all of the strategies that we used from the math no calculator section should also apply to the strategies in the math with calculator section, as well as all the general strategies that we have discussed so far. Make sure you watch the other two videos, if you're watching this in the future, the other three videos, right? Make sure you just watch all of the other videos in this SAT Prep Strategy series, because some of them include some general strategies that I don't list in every single prep video. And I'm not just going to do a general strategies video, because the problem with a general strategy is the fact that with general strategies, it's less important to implement, general test-taking strategies, which can easily be taught to you by a teacher and are pretty useful on their own, or they're just self-explanatory, or it's just an optional way to help you with time management or things like that. So just check out the other videos in this mini-series, and good luck to you. And once you finish watching this video, I just recommend you checking out all those other videos. Just like the other ones, we have the SAT Prep document in the description below, okay? Check that one out. So I'm going to be going over some problems. We have some sample problems this time, unlike with the reading one. Alright, so our first strategy that we're going to go over is called Formulate before you calculate. Now, that's a cute name, but what does it mean? Formulate before you calculate means that you should actually conceptualize the problem, understand how you're going to approach it before you actually start inputting things into your calculator, right? So many people feel inclined to just read the question and then push the buttons on their calculators as they read the question, or as soon as they finish reading the question, to try and solve the problem. They don't even try to conceptualize it or map out how they're going to solve it, right? Which we went over how to do that using keywords and conceptual maps in the last math strategies video, which was the math with no calculator. So I recommend you check that one out if you haven't already. So just note that I'm not endorsing this approach, by the way. It is completely wrong. Instead, you need to try and conceptualize the problem, as I said before, beforehand, map out the problem, map out the means to solve the problem, and then you can use the calculator, alright? The calculator is not a means to an end. It's the tool to speed up the overall process. Remember that for this math with calculator section, it just means that you're allowed to use a calculator for this section. It doesn't necessarily mean that it is required. It'll make the whole thing a lot easier for you and a lot faster. However, it is not necessarily required. So if you don't have a calculator, then you're fine. You don't necessarily need one. It's just a lot faster and easier if you do in fact have one with you. So remember to bring your calculator. That should also be a strategy. Don't forget your calculator. That's an important strategy. And then our next strategy is keep writing. So don't leave things in your head. All keywords should be written down, as we did in the last math strategies video. All data, all information, you should have all data and any information that you think is important or that you come up with should be written down on the paper. Even while you're using your calculator, each step that you write that you type into the calculator and then you press the equal sign. Each time you press that equal sign, you should actually put that next to your on the paper. So say you're trying to solve 24 times 32, but you're doing it the long way by doing multiplying the 10s to the 10s, the 1s to the 10, the 10s to the 1s, and then the 1s to the 1s, right? Say you're doing it the long way, and this is just an example. You're not actually going to do this. You're just going to type 24 times 32 into the calculator, of course. That would be dumb if you didn't do that. But let's just conceptualize it as such. Say that this is a multi-step problem and we're doing this like that. So we'll break it down into the so first thing we'll do is we'll break it down into the 4 different steps, right? So it'll be 20 times 30, and then 20 times 2, and then 30 times 4, and then 4 times 2. We are going to input these into our calculator, right? And then, once we input them into our calculator, each step we're going to record and we're going to write down, right? And then the last step, of course, is adding up all of those together to get the final answer. So 20 times 30, well, that's pretty simple. When you put that into your calculator, you're going to get 600, right? 30 times 4, you're going to get 120. 20 times 2, you're going to get 40. 4 times 2, you're going to get 8. So as you input these into your calculator, you're going to write them here. And then your last step is to add them all together, right, in your calculator. So what you shouldn't do, 20 times 30, right, then save that in your head, then do 30 times 4, save that in your head, 20 times 2, save that in your head, 4 times 2, and then save that in your head, or just not write it down anywhere. You'd have to like go up on your calculator to see like your history, right? That takes way too much time. What you should do is you should just map out all the steps first, because that's important. Remember, you need to conceptualize. You need to formulate before you calculate, right? Formulate before you calculate, okay? And then once you do that, you need to jot down each step of the process. Make sure you write down each one, and then that'll help you so that all you have to do is you just need to write down all those values in the calculator, press that equal sign, and then write down that answer, and then you get that the answer is 768. Okay? So that was a pretty simple way of solving the problem. And so our next strategy is using data charts, right? So data interpretation is also a part of the math with no calculator section, but also a part of the math with calculator section. And so this is just a way to interpret it a lot easier, just for both math sections in general, okay? So what you need to do is you need to understand how to use them properly to increase efficiency, accuracy, and time management, all right? So before reading the question or questions that follow the chart, you need to understand what the data is implicating or implying. Read the title, the axes labels, and a few key characteristics. Just a few data points if you need to, right? Then you can read the question or questions. Identify keywords as mentioned in the math with no calculator strategies, and look for the solution with the information in the chart. And so if you go onto the document, this is the chart that you'll see. Here's a quick view of it. Pause it if you need to see more. All right, we're moving on. And then we have our sample question. Pause it if you need it, and we're moving on. Okay, we're going quick, guys. So the scatter plot shows the height of 4 different plants after a month of time. Each plant was given a different amount of water per day. Okay, so we know that there are 4 different plants, so we're jotting down our keywords. Okay, and they were given a different amount of water per day. And by the way, before I actually did this, right, you should have already looked at the chart, read the fact that it's like plant height after 1 month, height, meters, is the y-axis, and then the water in liters per day is on the x-axis, right? And then just look at a few data points. You're like, oh, it goes up and then it comes back down. Is that one an outlier or is that important? Okay, you have to infer that. Okay, so you should have done that earlier. Either paused the video or clicked off to the document. Either one. Just checked out that data chart before actually doing the step, right? But I'm just gonna quickly get into the step, right? So, and then it's been a month time, so we know that it's been a month based off of the title of the data chart. So we know that it's been a month's time, so we can either multiply the amount of water that they take in a day and multiply that by a month. But remember that the amount of days in a month actually varies, so we don't know how many days have actually passed. So that information we can tell because we've actually we conceptualized. Oh wait, that information won't actually be necessary. We can actually cross that out, eliminate it from our keywords because remember that's not actually important. Okay, and then we're given height versus water intake in our chart, right? And so now If everything is kept constant between the different plants, all the other factors, what would be a possible height? So what could be a possible height? So that is the question. So what is a possible height if the plant is given 3.5 liters a day? Alright, so now we know what our question is, and we know what information we're given. We know some keywords. Now we need to start eliminating. We've already eliminated this as we were going through, which again you can either do as you're going through, but remember some of the information might actually be useful to you when you finish. You're like, oh, I actually need that. So you can either do it because you're actually thinking about it as you're going through, and then you actually have to think about it with complexity, and you have to think it thoroughly, right? So think about this thoroughly. Does it really matter that there are 4 plants? No, it doesn't, because the amount of plants that are given in the data set doesn't matter. Now what does matter is the fact that we know that there's only 4. Now that means that we have a limited amount of data. If there were like 20 different plants, then we would definitely be given a much wider range of correlative values. However, we're not. So this is in fact, so the fact that we know 4 things, it's not going to help us solve the problem, but it does help us figure out a way to conceptualize the problem. So this is in fact important. But is it important to know that there are 4 plants? No. What it is important to know is the fact that there are very few data sets in the chart, which you don't even need to read the question for. If you just look at the chart, you know, oh, there's only 4 data sets there, right? There's only 4 points. So is this information really important to write down? Yes, it's important to write down. You should write down everything, of course. However, is it important to, keep it written down? No, we don't really need it. However, now that we've written it down, we're going to remember it, all right? So, different amount of water per day. Well, you can see that in the chart. So that's just information about the chart, which you can see in the chart. But writing it down helps you understand the chart better, okay? And then height versus water intake. So we need to know that it's height versus water intake. Well, you can see that in the chart. So none of these keywords are actually important. The only keyword that is important is 3.5 liters per day, all right? And then the question, what is a possible height? Now, possible is also an important keyword. Why is possible an important keyword? Well, because it's not saying what would be the height at 3.5 liters per day, because you don't know because it hasn't been measured. You can't say for sure unless unless the results have actually been produced. So in that case, you're given the choices: A, 1.5 meters, B, 1 meter, C, 0.8 meters, and D, half a meter. Okay? So those are your choices. So let's start off by looking at the data chart. We've already looked at it, a little bit, did a quick, scan of it, read the title, we understand what it's about because of all our keywords and are looking at it before we actually, went into the question. But let's go back to it as we recite the answer choices. So 1.5 meters, well, we see it goes up, but then it goes back down, right? So that means that, is it likely that at 3.5 meters, it's going to hit that max of it's going to hit that 1.5? Well, not really, okay? So we'll say that it's not likely. So because it's unlikely, we're going to say that it's probably not the answer, okay? 1 meter, well, our data at 2 liters per day, right, says that it's 1.1 meters high. So if it's 1 meter at 3.5, then I'd say that's a likely answer. So that's a likely answer, so we'll put a check mark next to it. 0.8 meters, I'd say that's also pretty likely, maybe not as likely because it's 0.7 at 5 liters per day. And because it's 0.7 at 5 liters per day, then we know that it's not as likely, and it's really close, maybe a little bit too close for comfort, so let's cross that out. 0.5 meters, ridiculous. No, definitely not. So this is our answer, and in fact, 1 meter is the correct answer for this question. And why is 1 meter the correct answer for this question? Well, because if you look at it, the way that it's shaped is it kind of looks like a quadratic, okay? So because it looks like a quadratic, you can map it out and you can see, oh, well, the maximum value should be around 3. liters per day. If you actually take the time to draw over the graph. And so you would say, oh, if the maximum is at 3 liters per day, well then at 3.5 liters per day, it can't be 1.5 meters high because that would be over the maximum. Because when you're tracing it using your line of best fit, you would realize, well, that would actually be higher than the maximum or at the maximum, right? Depending on how you draw it. And so you would say, no, that's ridiculous, all right? That's impossible. Next strategy, know the question, right? We actually did this in our when we went over the last sample problem. How did we do it? Well, we wrote down what the question was, right? So when you read the question, don't get distracted by your work or your calculator, okay? Remember what the question is asking you for. So if it asks for the value of x and you discover y, you need to find x. Don't just, as soon as you find y, you're like, oh, done, found the answer, and then circle it, right? Because then the SAT knows that that's what you might do, and it tricks you into choosing that answer, okay? So know exactly what you're looking for. Make sure to write down the value you're trying to discover, just like what I did, find the height at 3.5 liters per day, right? So write down exactly what you're looking for, and then use your keywords to help you determine what you're looking for if it's not specifically stated, or what you'll need, as well as what you'll need to solve the problem and how to solve the problem. After you determine a possible solution, look back at the question, which we did, and make sure that you answer the question correctly. Is this a possible height? We'll do a sample question for know the question strategy. We already did one for the last one. Let's do one again. Okay. So it's if n plus 7 is equal to 3m minus 9, what is the value of m plus n? Okay, so that's the question. What is m plus n? That's the question. If m is equal to 5. Okay. So we know that m is equal to 5, so we already know that we're just looking for n plus 5. Okay? So that is our formulate. So what are we trying to formulate? Well, we're just trying to solve n plus 5, right? Well, we already know m is 5, so we can just plug that in. No calculating needed so far. Don't need to plug that in here, right? There's no point. So we're just trying to solve for n plus 5. Alright, so this is what we're actually trying to solve now. What is this? Well, what we can do is we can also plug it in here. 3 times 5 is 15. So we get 3 times 5 minus 9 is equal to 3 times 15. 5 is 15. 15 minus 9 is 6. And so we get that 6. That's also equal to n plus 7. Now we're just trying to solve for n plus 5. So we're formulating before we calculate. So should we just subtract 7 and then plug that value back into n? And find that value of n, which is going to be negative 1. And then plug that in there? No. Why would we do that? Just subtract 2 from both sides. Why? Because that gives us n plus 5. There you go. No need to solve for n, plug it in, and then solve there. We just get n plus 5 is equal to 4. And so that means that m plus n must be equal to 4. And so that's just a simple way of simplifying the problem. Why would you, plug things in, solve, plug things back in, when all you can do is you can simplify the problem and then there. And so actually we're going to get into the next step, which is check your answer. So let's actually plug this in. So knowing that n plus 5 is equal to 4, well, we know that n would be negative 1, right? So then we'll plug that in. Negative 1 plus 7 is equal to 6. And then 3 times 5, 15, and minus 9 is also equal to 6. Boom, 6 equals 6. We know that we solved this problem correctly, and we know that 4 is the correct answer for m plus n. And remember, we're solving for m plus n, not n, or not m. We're already given the value of m, so we're not just looking for m. Okay? So make sure you know what the question is asking you for. And so our next question is check your answer, and what I recommend is that for check your answer, and actually for the rest of the questions, for the rest of the strategies, I recommend that you just go to that document, read them there, put them into practice, okay? Because there's no point into me just reciting what I've already written. So check out that document, and I'll see you in the next video.